fill in the perspective in terms of what is the end user expectations and the gaps that we see in the current constellations and the ground segments, which we and how we fill those up. So that would be my contribution to the discussion at this time. Thank you.
Hi, my name is Vaibhav Magow, and I am Vice President at Hughes. My responsibility is to generate sales, and I lead the sales for what we call as rest of the world. That's most of the markets east of the Atlantic Ocean, covering the CIS countries, Middle East, Africa, China, Asia Pacific, Middle East, Africa. So lots of territory for me that I look after. And in my experience for the last 25 years working with Hughes, I've had the pleasure of seeing how the ground systems have evolved and what kind of roadmaps we're seeing going forward. It will be exciting to share what is shaping the upcoming ground systems and what kind of technology we're going to bring to the market, or as Hughes we're looking to bring to the market. In general, the industry is moving in a direction where there's going to be more bandwidth available. There's going to be more demand coming from customers. So really, the big focus is how do you really bring down the cost of satellite broadband access, be it GSO, NGSO platforms, etc. Ground systems, the chair here, Mr. A.K. Anil Kumar, also mentioned that there are other ground segment areas as well for GPS like NAVIC, and of course for missions like Chandrayaan, etc., which is not an area that Hughes looks on, but definitely when it comes to satellite communications and broadband communications, look forward to contributing to the discussion. Thanks.
Thank you. Just to set a stage for our topic, although it's for ground segment, this panel was created with a view to have different inputs from different areas, whether it is from the space or from the service provider or end-to-end services, right from hardware manufacturer to owning the satellites and operating. So that being the case, we have seen this industry evolve from a long time, which happens in other industries as well. But in our industry that is more on satellite communication, things have been going slow and suddenly there are big changes. So like the space or the satellite as a bird, same way the ground segment also needs to be evolved and innovated. And all that happens in two ways. One is the technology which changes, and second is the experience and the challenges we face in the field. So in the entire game, one of the aspects is the human capital and the people's competencies, skills in deployments, in maintenance, in running of the networks. So just to give a thought, these are some of the live examples of installations. It's a real simple vanilla installation of a simple VSAT terminal, may it be at a petrol pump or an ATM for different applications. So then the question comes that how good is our installation team or the field maintenance team? Because if you look at it, for example, DTH, it's just a receive-only terminal where you have a small monitor, you look at the image, You do a rough alignment, you look at the image, look at the sound, you tighten it, it's done. But when it's a trans-receive terminal, then you are pointing it from the ground to a bird which is 36,000 kilometers up in the space. Or if it comes to LEO or MEO, it is less. But then it has its own challenges of its trajectory and all of those things. So then we come to a point where we say, why training is essential? Basically, capacity building for installation, maintenance, and operations. So,
before you can become an expert driver, you need to learn how to operate your car so you don't injure anyone else. The same idea applies to setting up satellite terminals. The most important thing you must always do, no matter what, is to avoid accidentally causing interference to other people's signals. That starts with accurate pointing, accurate cross-pole alignment, and connector attachment workmanship. You will cover these issues and more very strongly in this course. Aligning the antenna for polarization is a very critical skill. You must do it right or you will interfere with someone else and you won't even know the damage you've caused.
So this was just a brief spec in the kind of trainings available online today, which a technician or an engineer can study on his own and then go through a hands-on test to validate what he has learned. Here, this kind of training or capacity building is not for a person to pass, but to learn. And that being said, it's very vital that they practice more hands-on. So that gives us some perspective of the importance of training. Now, another aspect to it is, earlier when we used to install, I'm talking about a remote terminal, it was usually a 2.4 meter antenna. As the technology advanced from C-band to KU and others, and as it proliferated, the antenna sizes went down. It was 1 or sub 1 meter. Numbers exploded. And we meaning the satellite industry, became a victim of our own growth. How? The quality of antenna terminals, ground systems, and the quality or the competency of the installer made all the difference. If you don't point properly, you interfere. Now there are so many facets of interference, whether it is an adjacent satellite, interference on the adjacent satellite, or a radio interference, and so many things. This is not the time to discuss on that. But then those were the challenges. But today, what has happened is that skill set required for installing a small terminal and skilling the person has slowly gone down for the reason that the equipment has also evolved and grown. Like auto pointing antennas are there, flat plane antennas are there, phased array antennas are there, which would automatically do, which means the field skill set has moved into manufacture and optimized. However, you are addressing one aspect of it, but there are so many other aspects required to run a proper ground station. So that we will explore more on this. And here are some of the images of the kind of mentored trainings done with the satellite operators for their customers, for UN agencies, for emergency responders, for service providers, and for the military for disaster management or communication. So that being said, I will, this sets a stage, and I had taken a few points. So I purposefully provided a glimpse into one facet of the ground station systems, which is vital and has a lot of implications, to set the stage for this discussion today. In our industry, the key focus is to provide more capacities, higher speeds at a lesser cost, while ensuring robustness and reliability of the link and connectivity. Today, we have a mix of GSO and non-GSO, terminals access. And I mean, from GEO, LEO, MEO options, we have multi-orbit as well as multi-band options. So how does all this affect an end user? For an end user, it's only the quality of the link and reliability at a cheaper price. What goes behind is what we as a person in the ecosystem, whether as a manufacturer, as an operator, as a service provider, need to think on. With that in mind, let's explore the latest developments in innovation in the technology, particularly focusing on the ground segment. It is possible to have a single terminal that can seamlessly operate across multiple orbits and multiple bands. And also let us look at it, how AI is affecting our industry at large. So this is how I wanted. Now, what I would do is, I would request Hughes to throw some light on it. I have a one-page pointers to hold on for you to speak, Vaibhav, and then we can take it forward.
Thank you, Riaz, for that kickoff. And the central point in our industry today really is that satellite communication has been around for a long time. But what we see today is that there is more and more interest coming in because of the low cost of access to space. So the whole launch cost, the whole launch industry has made it so exciting right now that getting to space is becoming cheaper. And that has opened up the whole business model in terms of what can you take there, how often can you take there, and how often can you innovate. Earlier, when you used to launch satellites, you had a huge life cycle that you took 5 years to build a satellite, design, plan, where do you want the coverages, what kind of geographies, what bands you want to use, what kind of coordinations you have for the slot that the satellite will go on. So you had a lot of planning activities, took 5 years probably before the satellite was actually in its slot and would transmit. And for 15 years, the satellite is being used. So the life cycle of innovation is so slow, it's 20 years. But now what's happened is that with the access to space becoming lower cost, the kind of satellites which are coming up, the kind of innovation that is coming up in manufacturing the next generation of satellites is becoming, is at a pace which is unseen before. Right. And what's happening because of that is the whole context of making satellite relevant for the user is increasing. So earlier people used to see satellite as expensive, bulky, very technical, a lot of training required. You need to have experts to run the system or to install the system, things like this, which kept us as a very niche part of the communications industry. But I think there's a whole lot of change which has now been set off. And essentially, on the left-hand side of the slide, you'll see 3 very important changes that have been brought about. The first one I would like to talk about a little bit as a change coming in is the advent of satellites, which are not just having spot beams, but are having a very large number of spot beams, and with a very large spectrum for uplinking. So it's not just 1 or 2 gateways. There are multiple gateways that the satellite has. And you're not only talking about uplinking in Ka band, you started to talk about using a quad band uplink. So using Q band, V band, and Ka band to uplink. The total amount of spectrum that you're able to uplink from a ground station, an earth station, up to the satellite, to the tune of about 30 gigabits. Typically, give or take, it's about 15 gigahertz of spectrum that you get on the QV Ka band. And if you take 2 bits per hertz as a simple rule of thumb, you get to about a 30 gigabits plus kind of an uplink to the satellite. And then from there, you have now started to get these flexible payloads wherein you can distribute that spectrum to multiple user beams across the coverage and the field of view that the satellite has. and you can distribute this 30 gigabits over multiple beams. Some of the new satellites which are coming up, the antennas are very, very capable. They have got electronically formed beams. You can change during the lifespan of the satellite. You can change the shape of the beam, the number of the beams. You can also change how much capacity is going into which beam. You can take capacity from one beam and you can put it in another beam. Very simply put, let's say, a country has a big project for 4 years, 5 years, and a satellite operator puts the capacity over that country. After 4 or 5 years, the country stops funding that project. Now that capacity has become available. In an earlier generation satellite, for 15 years, you're locked in. The capacity is just lying there. You cannot reuse it. You cannot do anything about it. But now with the flexible payloads, you could redirect that capacity into another geography, another area, another place, and continue to use that satellite and generate commercial profits from it. So what's happening because of flexible payloads and VHTS satellites, the cost per bit is coming down tremendously. Hughes last year itself launched one of the biggest communication satellites today. It's a very high throughput satellite. We call it the Jupiter 3 satellite. A single satellite having the ability to communicate 550 gigabits of capacity over the Americas. So very large space, very large coverage area that we have, and also a very large throughput. It's a completely QV band gateways. These QV band gateways, which you see on the right hand side, the top part, the innovation that is coming in here is that because of this, you are now able to communicate with the satellite. So I have to build only 18 Earth stations to fill up the 550 gigabits. Earlier, if I was using the earlier generation platforms, if I'm using Ka-band has got only 3 gigahertz of space. 2 gigahertz is typically used for the uplink, and about 500 megahertz is typically mil band. In some countries, they don't allow the military band. 500 megahertz is kept for the user beam. So, and you keep reusing that 500 megahertz to keep multiple spot beams. But the 2 gigahertz gives you about roughly 10 gigabits. If you do a little bit more, you stretch, go to 2.5 bits per hertz. You can get up to 10, maybe 12 gigabits from a single gateway. So if you have a 550 gigabit satellite and each gateway is only giving you 12 gigabits, the number of gateways you would have to put, the number of antennas you would have to install, the cost of delivering that capacity, that bandwidth to the end user becomes higher. So by coming to Q and V band gateways, requiring lesser gateways, lesser space, makes it more affordable. At the end of the day, it all adds up to price. Becomes more affordable for the end user. Give you an example. Our first generation Jupiter platform, the system, the ground system, one rack, we used to uplink 2 gigabits. In a single rack, we used to uplink about 2 gigabits. In the second generation Jupiter system, we took that in a single rack, we took that to about 8 gigabits of capacity. In our Series 3 latest generation system that we have, a single rack, we can put up 33 gigabits of capacity. So the footprint of the ground system, the amount of electricity consumptions, the amount of electronics used, the amount of sparing required, amount of maintenance, wear and tear is so vastly reduced. So these are some of the changes which are impacting. The last part also, Riaz touched upon, which is multi-orbit, LEO and GEO. And that's also an interesting element because now with the NGSO, the non-GSO orbits being available, it is bringing a new set of capacity, a new set of solutions possible. And most importantly, I would like to share with you one of the bullets over there. You'll see the second last bullet, which is the electronically steerable antennas as a technology. So Riaz just talked about that, how in the geo satellite space, the antennas have to be carefully pointed, there is misalignment and things like this, which adds to the cost of rolling out terminals. I'm involved in a project in Indonesia, which is done by the government under the USO project. And they have bought about 150 gigabit satellite they've launched. and they have to roll out 40,000 terminals to provide satellite backhauling, mobile backhauling, and internet access in the rural villages. The cost of going across to 17,000 islands and installing these 40,000 sites, putting the installer, sending the installer, shipping it in the equipment, the cost of the last mile installation and the logistics is more than the cost of the terminal. The customer is spending $2,000, $2,500 only on the last mile access. The terminal cost is not so much as the cost of the logistics. So what is happening with the LEO constellations and because they are closer to the Earth, for a long time our industry has been talking about bringing an antenna technology wherein you don't need to point, you don't need to manually and figure out all of these things. Automatically the system using an electronically steerable antenna will look at the satellite, look at the plane, automatically adjust and bring down this humongous cost of last mile fulfillment. On the LEO side, because the orbits are much lower, today you use much lesser electronic panels to be able to put up such an antenna. So it's become much more easier to build such an antenna for commercial purposes. So we have started now building antennas for the OneWeb constellation, and one of our panels, we call it HL 1100. It's less than $4,000. You can get a terminal. It's got 18 months of warranty, etc. It's a fully commercial product. And if you try to build this for a 36,000 kilometers GEO orbit, you'll require much bigger antenna, much bigger much more panels, much more expensive. So the LEOs are also now increasing the innovation happening in the ESA side. And with the innovations that it is bringing in, hopefully this would also mean that the next generation of ESAs would be able to become more cost affordable for the GEO as well. So we're already looking at how our experience of building LEO antennas would also help in the other orbits as well. So it's becoming easier to install. There's more capacity available. It's bringing down the overall cost. And then there is a whole lot of other things which are happening around this. I think I've already touched. Higher density gateways basically means that the total gigabits that you can send from these has gone up. It's a very flexible ground system. So like we mentioned, all of these use cases that you can change the beam, you can change the number of beams. So the ground system automatically, you don't have to worry about how many demodulators and modulators I have in the system. There's all software defined now. You can generate carriers just by changing the software configurations. Multiple carriers can be generated from a modem over time. So today, if I'm serving a territory with 20 beams, tomorrow I serve the same territory with 40 beams. So how will I now go? What do I do with my hardware? Do I have to go now build another rack and put more rack and start shipping racks? No, that's not required. The software can be built. So this technology is available today. We are installing it today. We are delivering it today. Another last part, you talked about AI ML.
Yeah.
And I'd like to share there. I think one of the challenges that this brings forth is earlier the satellites were much simpler, much smaller, lesser capacity, lesser carriers. Now with more capacity, there are more carriers, multiple carriers. There is multiple cases of interference that can take place or things which need to be corrected and looked into. And it is becoming humanly impossible to sit and configure so many return channels, so many forward channels. It's becoming humanly impossible to be able to continuously doing, the modulation coding and seeing whether in rain, do I have enough number of return channel? Am I choking in my network? Should I put on more return channel? So there is a lot of change happening, and AI and ML algorithms are coming in. So one of the things, for example, is dynamic provisioning of carriers. So based on the traffic, based on the weather conditions, the system, if you define start and stop frequencies of your transponders, will automatically spawn carriers of different sizes, increase the number of carriers, decrease the number of carriers, so that your engineers do not have to sit and figure out, oh, right now complaints are coming in that people are not getting enough bandwidth because rain is there. Because there's rain, the terminals are not transmitting at very high speed. So the capacity has gone down. So because the capacity is now gone down, a lot of my bigger carriers, my terminals are not able to lock onto because there's not enough power in my radio anymore. So now what I have to do, I have to start having smaller carriers, but it's only 2 hour rain. By the time I manually start creating new carriers and bringing down larger carriers, rain will also have gone away. So now, during having dynamic provisioning of carriers, gets done automatically by the system. It's all automatically taken care of by the system. It spawns, removes carriers, brings on carriers. Then with AI ML, what we're doing is that all the problems that come and which require triage, which you have to sit and find out that what is the cause of the problem. So you need to first figure out that where is the problem, how to fix the problem comes later. But a lot of time is spent in knowing where is the problem. So using AI ML, using the deep learning as to what earlier was done, the earlier cases, how the problems were rectified, the system automatically starts informing the engineers that there could be potential problems because of XYZ factors in the network, because of XYZ conditions in the network. So there's a proactive mechanism to tell the engineers that please look into this, and reasons are given so that the triage is faster. You don't spend a lot of time finding out where the problem is. And that's where AI ML is coming in. And at Hughes, we envision creating a huge data lake of all our global systems so that there will be even more opportunity for deep learning so that we can do even faster triage and faster problem solving. That would reduce the number of people required to man these gateways, these large satellites, these large systems, again thereby bringing the cost down and the price down of the bandwidth which the users want to use. So these are the kind of innovations in the ground segment area that are today very much in place, and I think the pace is only getting stronger. The innovation cycle is getting even better. There are so many things happening. I thought these are some of the things we could just kind of talk about today. Be happy to let you know more about it if you ever need to know so. Back to you, Riaz.
Yeah,
Thanks.
so thank you, Vaibhav. The example you took about Indonesia and rolling out humongous number of terminals itself points out, and the numbers you shared as well, the logistic cost of reach, that is one time only to install. And then there's a question of maintenance and service also. So all that goes down with technology evolving, smaller terminals, user installable plug and play kind of systems. And we could also understand that as the satellite and the space segment changes and innovates, similarly matching ground system needs to be there to operate in unison. That being said, ultimately from a user or a customer's perspective, what should they select given the variety of options available? For a user, it's confusing whether, I just want to communicate. So whether I should go for LEO or GEO or MEO or this band or that band is what is needed. And then again, there's a cost benefit on that, on the hardware and the usage, both. So ease of installation, stableness, and with that in mind, what is the kind of ground system support and the human aspect required to manage it? Do they need to be trained resources? Do they need to be active and be more involved on the ground? How? So that's the first quick question to you.
So absolutely, I think as you keep this evolution cycle on, there are so many new challenges that you come across, and you've got to obviously mitigate all of these. So for an end user today, I think the focus is very clear. Now look at the Indonesian case that we brought up out here, right? The cost per gigabit, okay, for that project is somewhere around $60 per megabit.
Mm-hmm.
Okay, that's it. If you look at the kind of costs we are seeing in Latin American markets, etc., where we have our own satellites and
right,
we are providing service, we're competing with Starlink and all of these people. The prices are like $15, $20 per megabit per month. That's the kind of price that you can get from the market, and the prices are starting to come down to single digit. India is far away from those kind of price points today. So I think for users, at the end of the day, they don't see whether it's a GEO or LEO, right? It's not about the latency really doesn't is not really a big play in most
Yes.
in networks. In some cases, yes, you do have latency requirements, but in most cases not. So, so today, really, the users are very much clear. They want speed. Give you an example. Earlier, before Starlink came, and we used to tell our customers that our modems can do 200 megabits per second, each of our modems. So use these modems, right? A lot of the modems in the market come licensed and they have extra cost to pay. If you get more speed, then you pay more money for the modem. Same modem becomes more expensive. So we don't do that. So we should tell customers to take such kind of modems because it's like $200, 200 megabits kind of speeds you get. Now, the same customers are coming back to us when Starlink is in their market and they're saying, we want to take your system, your modems, because we can, with the GEO system, we can now also give 200 megabits. Earlier, the customers were asking us only for 4 megabits, 5 megabits CIR, but now everybody wants 200 Mbps MIRs. So,
Right.
so I think for the customer, speed and price is the most important.
Sure.
And it doesn't really matter so much. You asked at the end, the last question was on training. Yes, I think more and more education and training is needed to make sure that some of these complicated use cases, scenarios, etc., this flexibility at the end of the day that you have to deliver, you need trained people to understand what they're dealing with. Because right now you're worrying about the interference which is happening from the terminal only.
Right.
But the moment you start playing around with the spectrum on the satellite,
It's
right,
humongous.
it's a humongous amount of, the adjacent satellite interference that you can get, or the CSI values that you have. So the moment you change the beam architecture and you change the frequencies dynamically, you also have to be very watchful and careful in terms of what kind of interference the satellite itself will generate. Right. So, and it can impact the total capacity of the satellite that you have. So definitely a lot of training, a lot of education is needed. Use of new tools, AI, MI kind of tools which are needed to look into these scenarios and cases. So those are my responses.
Yeah, I just want to
So
comment.
another question. Yeah.
I want to comment. While we are discussing about the user community, the cost effectiveness. So user want a less price and get high speed, maybe 200 Mbps, etc. They want the bandwidth. But apart from that, the space is dynamically changing now, evolving so fast. I know as far as already, as we talked about, ground segments from mechanically steering or non-steering stationary to electronically steering things, and from hardware to software adapting that, single orbit to single band to multi-orbit, multi-band. All those things are taking place. It is we are progressing well in that session. And also user may be getting, presently in the whole world, all the users are, maybe Africa, that is why Africa is, and other areas where Asia Pacific area, etc., they were concentrating for the community to get faster internet facilities. But you see, space is dynamically varying and space technology is varying, onboard things are varying, carriers are varying, frequencies are varying. How to tackle those things? Not only that, the ground segments, are we matured enough for the ground segments? So many thousands of satellites are coming. Are we matured enough in ground segments to give the service? Actually, earlier, it is not service. Earlier, maybe before 20 years back, it is for the operator or owner. They want to have many things and they will be using it for defense. Now it has become a service, commercial product. So how that change is taking place now, how we are cope up with that, mature enough for that industry. I have 3 industry people here. I am not from industry. I request industry people to answer for that.
Okay, I could start and then maybe. So definitely a lot of changes happening. We understood from Vaibhav and Riaz what all changes have happened on the satellite segment. The flat panels which are coming up. LEO India is just warming up right now, and I'm pretty sure pretty soon those ESI systems will be active here, probably this year itself. But globally, it has taken up already. We have seen likes of a couple of constellations already which are operational globally. Now, traditionally, when we saw the first images which Riaz put up about those antennas, that took me almost 2 decades back when I used to physically set up those antennas as a field engineer as well. Now everything has changed. All flat panels. When the COVID lockdown happened, because we are a global providers and we provide remote operations, the biggest challenge for us was sending a field tech out to work because it needed a skilled engineer. Now people don't really need field techs to go and visit because the flat panels can just be installed, and with your mobile phone itself you can align the system and bring it on. But there is a change, there is a catch. All these systems from the are moving into a proprietary ecosystem because of the constellations of big constellations that are coming up. Previously, a user could buy any technology modem and he was free to choose the service providers and free to use them with multiple service providers as he wanted. Now that's changing. Now once you buy a package, package comes with, because it's sold as a service. So the package comes with its pros and cons. Package comes with its feature pack, but it also comes with the set limitation only related to that constellation or that offering. So there is a gap which needs to be filled. However, the gap is smaller, but there is a gap when it comes to critical communications. And for that, there are more and more use cases that we are seeing and which we are deploying, where we are actually wanting to deploy 2 different constellations or 2 different type of technologies in parallel and trying to balance out both the network capabilities to achieve the maximum results. So yes, cost has gone down, which has enabled all this. The space requirement, the technology has actually improved such a bit that it is becoming ease. But at the same time, the more and more, end of the day, why is this communication needed? This is needed for human beings. This is needed for people to get connected to whatever connectivity requirements they have. So as the connectivity is easing out, the mediums of connectivity is easing out, the requirement is also growing drastically. Previously, people used to have like a 1 MB or 2 MB kind of a VSAT connection. They said, okay, this is sufficient for us for 50 people on this particular location. Now with this 200 Mbps/40 Mbps kind of connections, we thought that, okay, from 1 MB they are transiting to 200 MB, but they're still needing 4 of these systems on board. So they are not happy with one. So as the technology changes, the user demand is also growing. The expectation of the network reliability and stability is increasing. So that definitely is an aspect that we could see from the user side.
So Jayesh, my quick question is, your company is into multi-bands and multiple, even multi-bands and multi-orbit. You claim to give assured uptimes and quality, right? So for the customer, it is irrespective what they are doing. That being said, what is the kind of assurances that you all normally give to your users as far as the SLAs are concerned? How is the uptime? Because everything is now digitized and digital controls and all are there. And you have a varied kind of customers, whether it is marine or whether it is land or even airborne. So can you throw some light on it?
Sure.
And just a second. And how do you support the ground systems?
Okay. So twofold. So I'll answer the first part first. So yes, we have a very different variations in the type of customer base we serve. We serve everyone from government to NGOs, which are I would say low sensitive but high availability requirements, to a business critical oil and gas kind of an environment where everything is IoT based and the instrumentation is the key, and being online is very important. So depending upon the type of market, we definitely always opt for 2 or sometimes even at some places we even have 3 different barriers of connectivity. So different types of medias from LEOs, MEOs GEOs, which are always one of the most reliable part of connectivity, to we also go with LTEs or ground-based terrestrial networks, which are also sometimes required for scalability aspect. Now, with all those put in mind, the end goal is for the user to be able to use their applications the way they want. So with that in mind, what we do or what we offer is we have basically converted the whole network part as a service. We call it network as a service, NAS. And the offering is more on the service level, not on the network level. So regardless of what type of multiple network bearers that we use, our SLAs towards the end user is more related to the uptime and the network uptime, not just the connectivity uptime, but it is the overall network uptime or the application level uptime. So we use different medias. We basically check all the boxes in the LAN, WAN, MAN managements, as well as the security aspects of it and the routing and switching aspect. But end of the day, what we are trying to achieve is provide a application level SLAs, and all those SLAs are based on different types of applications, and all of them are in higher 90s, I would say, at this time.
So, quick question to Dr. Anil Kumar. You have been mainly into the Indian ecosystem and mainly on the satellite side. So, what can you say about the ground systems that is required to match with the new technologies coming in?
As you know, as earlier I said, basically two parameters what we look is one is time and position, time accuracy, position, apart from the bandwidth what we require it. Now, so there are many advantages, many advances, actually research things are going on for quantum time systems which can give picosecond accuracies, and also quantum positioning systems which can give centimeter level. Earlier we were talking about second level and meter level, etc. Now we are talking about centimeter level and picosecond level. And as far as GTCs are concerned, if I come back from the satellite communication down segments to GTCs, like earlier here already said, phased array radars and all other things, all the new technologies, even electronically beaming, and same antenna can support for different bands. So S, X, C, different bands. All those things are coming in. So we are trying to cope up with the present technology and trying to mature our systems so that whatever the satellite requirements are there, and also satellite on board also there are a lot of different things are there. Accordingly, whatever requirements are there, we are trying to do not only in hardware but also in software.
So as you rightly said, even for satellite imagery, which can be interpreted for a number of uses for common man, right from agriculture to cropping patterns to mining to emergency communications in case of a natural disaster, to assess the damage and do, like you mentioned just now, with the small aperture, reading also with accuracy is equally important for getting the right information and more in-depth information, which can again be subject to machine learning and AI for interpretation, basically.
That's fine. Actually, earlier also here somebody said, he said telling 2.4 meter antenna. Earlier we were using, now it is sub-meter antenna we are making use. It's a compactness, which will automatically lead to the less power consumption and cost effectiveness.
Yes.
And AIMLS, we are also working on AIML technologies which can interpret even automate it and also reduce the efforts. So we are trying to do it. We are doing it.
So now coming to Mr. Vaibhav, Hughes so far is the largest broadband service provider in the world by number of terminals, therefore users, and the bandwidth consumption as of today. Therefore, and you in particular have not just looked at Indian, but lot of markets from Australia to Africa. So you have different use cases and different experiences. So a very quick question to all the panelists. Is there a single ground system which we can expect down the line which can work on different orbits and different bands? Yes or no?
So the question is fairly nuanced. The answer is no. But in terms of how you interpret the question, is, the nuances come from there. So when you say, is it the same system? So first of all, today when you build a constellation, the system is built for the constellation because
Yes.
depending on the orbit, depending on the number of the satellites, depending on the plane of the constellation, you got to really build and design the ground system. So it's not something that you can take a bespoke kind of a hub or something like this and start putting it on. These are not SCPC kind of links, right? So, and now there are also a lot many more technologies you can use. It's not just DVB-S2X. Now there's NTN and IMT
Right.
is also becoming an option that you can swing to. So there are so many more choices. So on constellations, really, it's a design-driven discussion, and what Jayesh said, it's really integrated into the whole platform.
Right.
So it's a very different approach. And for that matter, because the modem is different, the core modules are different, you really cannot have a single terminal. For a constellation, you have to do break and make because satellites are continuously moving.
Right.
So you got to make and break. So for example, the old O3B, you used to continuously hold the link, used to connect to the second satellite, and then let go of the. So you used to
The first.
make and then break.
And then break.
Okay. Now, when you come to the new constellations, you don't have to do that, right? You can break and make.
Make quickly.
Yeah, right. So you don't need two antennas. So again, cost comes down. So there are different levels of designs, etc., that can be done, and it's all up to the vision of what the constellation is meant for.
Right.
And so it's a nuanced answer.
Sure.
Short of it is no.
Okay.
Holy Grail, possibly down the road, once the NTN technologies come up into space, and we move more distinctly towards IMT and the mobile, using mobile chips, etc. That could be a point where you could see much more convergence starting to take place.
Mm-hmm.
But yet, whether it would be a single terminal, I mean, I think
There's still time for
that.
How about you, sir?
Yeah, presently my answer also no only. There are two questions, two parts you put. One is multi-orbit and multi-band, right? Multi-band, yes, now also problem is there, multi-band. But multi-orbit, usually same terminal works for multi-orbits with the same band, single band. And complications in the putting multi-band in say same terminal, same antenna. Now they has to be sorted out by industry. They have to mature enough. They should come out, and they have to innovative ideas required, or hardware as well as software. Both are required. Presently, it is not there. We are trying to put in ISRO also. We are trying to put two bands in a particular antenna. Recently, we put S and X in same thing for our TTC purpose. But like he said, for communication, we require KA, QV. Many systems are required, but it can be put in the same system. Maybe industry has to come out with the solution for that.
Jayesh, how about your view?
So yeah, my answer is no as well, for sure. At this stage, we don't see any such antenna being available, or not. I don't even foresee it in near future. And it's not just. I don't think it's a technology limitation. It's more about how the systems are designed. As Vaibhav said, it is more about the antennas are manufactured for that constellation, and the constellation is owned by someone, and there are multiple owners of different constellations, right? So we need to understand the commercial modalities now. Why would this system be needed? Unless there is a entrepreneur who thinks otherwise and says, I could tie up with all the constellations and make an antenna available which would talk to anyone. So that's something which is a slightly different approach, which could happen in future, but you never know.
Yeah, thank you. So I was just asking from the user customer perspective. So we can always safely say that users have to wait for some more time. And that being said, I open the floor for questions if anyone wants. I think we are running on time. And yes, sir. Just get you the mic.
Thank you. So my question is to Vaibhav. So after a few years, when we reach a certain point, when on our phones we start using a mix of SATCOM data versus telecom terrestrial data, using terrestrial infra, how do we at that point of time, how does the ground infra kind of take shape? What will be the changes?
So basically, what you're talking about is direct to handset. I think the industry is already working towards this. The non-terrestrial network is already defined now. The standard's already set, and that's the next generation technology everybody's working on. So there are two ways you can deliver it. One way you can deliver it is that you use frequencies which are assigned to the mobile operator. So when you hear Starlink is offering it, and you hear AST Link, there are many companies who are offering it. They essentially plan to use the frequency of the mobile operator. So the satellite would actually transmit the carriers, which is like a 5G, basically a 5G carrier, just like a RAN in the sky, and it would transmit that down to the ground, which would then be received, because my phone doesn't have a very strong antenna. So the link budget would not be good, not much speeds initially you can get. Right now, like Apple has said that they'll only do SMS, right? That's also only one way you can send, but not necessarily receive everything. So there are lots of current limitations because of what you can do. But next generation, already the chip manufacturers are working to incorporate more frequencies. So one of the other things that can be done is you use S-band to access, because S-band is very close to the IMT spectrum. So you don't have to modify too much. On the ground side, basically you'll have the same thing. You'll have a ground infrastructure, an antenna, earth station, but that would be essentially a base station. So basically it'll be like a mobile network operator's base station, and it'll uplink nothing but a regular 5G, new radio, NR kind of thing. So it'll be standalone system, and it'll get connected into the mobile network operator's network, and it'll be roaming agreements that will be signed between the mobile network operator and the satellite operator. And as a user, your mobile operator would have a tie-up with one of these satellite constellations. So when you go out of coverage area, you will simply roam into the satellite coverage area. So for the user, it will be largely transparent. Depending upon if you use the mobile network operators carriers spectrum, then he's paying for it, right? It's very expensive. So how many megahertz is he going to give for this communication will decide what services you'll get. Okay. On the S-band, because it's not something which belongs to the mobile operator, and hopefully licensing around it would be far more lenient than IMT spectrum, because you're not bidding for it. Hopefully that would probably be a lower cost, probably give you more spectrum, so you could offer more richer services to the handset. So this is the evolution, but this will take a long time. It's not going to happen overnight. But the industry is going in this direction very fast already.
Any more questions?
Yes, thank you, sir, for allowing me to ask the question. Thanks to the organizing committee to allow me to attend. Coming to the question, NGO satellites or non-GEO satellites have become very popular to give all sorts of services, in fact. And now, apart from non-GEO, we have got terrestrial networks and NTN, non-terrestrial networks as well. So currently, there have been much improved technologies. As talking about in India, for example, by the time we are building taking the example of internet, by the time we are building such types of satellite network, we already have fast fiber networks that are running across, and they can comfortably provide 150 Mbps. And while satellites can in fact give more type of coverage and more speed as well, considering in India the cost and everything, 150 or 200 is what people would be looking to buy. So how do you think fiber and NT networks would compare in the long run compared to, say, TN or terrestrial networks?
Who wants to take the question?
A very interesting question that you asked here. Look, in terms of the applicability of NTN, today, most countries, though they have a very high amount of cellular mobile service penetration, they don't cover 100% of all the geography. So I'm talking about countries as advanced as Japan. They would have 99% penetration, but in terms of the country coverage, the mobile network would have a country coverage only 70% or 75%. So there's still 25% of the areas where there is no mobile service available. So the first use case is that for the NTN is to provide coverage no matter where you are. So if you are going for a hiking, or you're going to climb the Mount Everest, right? You're going to base camp. You want to go and take some adventure sports. You are in the middle of the sea. You're not getting any mobile coverage in such areas. So the first use case is in such places you would be able to get the service through satellite or non-terrestrial means. The other use case is for emergencies. So in emergencies, when the terrestrial network itself is knocked out, then how do you communicate and send emergency messages to, let's say, areas and geographies who have got tsunamis or who have had natural disasters, etc. So around that, these are the initial use cases. Definitely, in terms of speeds, NTN will not be able to compare with terrestrial networks initially. Eventually, as technology will, that will take some time of evolution. It will get there, but initially it will be very few sets of services. So that's my response to you.
See, every time, what you asked is a very valid question. Every time, it's not the cost alone. It's a cost benefit between availability, coverage, usage. You take a simple example of an earthquake in a geography, and everything is gone off. So how would you communicate? It's only the satellite, right from a satellite phone to a man pack and all of that. Thank you. Any more questions, sir? Yes, sir.
It intrigues me that I belong to the telecom industry. 80% of this earth is yet untapped. Whether you see forest, see mountain, and yet satellite hasn't picked up so far. So how much more time it will take? Because this is one area which intrigues me to some extent. And time means 1 year, 2 years for in case it covers every area. Then how we pronounce that like it's applicable to a vast population which we think is not available. We think that cellular has done 99% penetration, 98% penetration. Actually, it is 80% is still vacant. So the ARPUs and everything which people calculate, that goes for a toss when we don't consider that. So won't it motivate the people to be there then? Currently, they are not using it there because it's not there. That's my point. I'd like to understand from the experts.
Well, I think NTN in 5G has been defined for this purpose alone, to not restrict the growth of the mobile networks only terrestrially, but also to look at non-terrestrial beams to accelerate the coverage of areas which otherwise will never get commercial coverage. So it's just new now, and I think the access to space is becoming cheaper, so it's possible to launch LEO satellites to start covering. I would say by the time you are to the end of this decade, you will definitely start seeing that dream come true that you're talking about, and many people are putting money into it, investing it. who will be successful at the end of the day, and who will actually make it there, who knows. But I think there's a lot of interest, a lot of investment, a lot of capital, and a lot of innovation, a lot of technology development happening on all of these areas to get there. I well, yeah, I think we'll keep pushing the boundaries further and further. And there's no doubt about it. That's a tendency of man. But overall, I think satellites would get there. The cost is getting better and better, and I think we'll become more mainstream. But just to end that, probably,
Yeah. Any take on that? So another value add to your question is that with Indian setup changing and more inviting to, moving away from the regulatory to an open setup in which private sector is also participating and coming forward. I cannot peg a number of 2 years or 5 years, but yes, it will happen fast, because this kind of conferences to everything is pointing out that we are open to work together.
At Hughes, at Acosta, in fact, we own global S-band spectrum, and we are working on the DTH space. We are looking at bringing out constellations, etc. Right now, pretty much doing that whole homework and studies. A lot of efforts going on in our own company, and we know of so many more companies out there that are looking to do this. So definitely, I think 2028 to 2030, you'll definitely start seeing a lot of maturity and availability of these services. It doesn't matter whether it's 4G, 5G, 6G, doesn't really matter, because today, if I roam into a village area and if I get 3G, I'm happy enough that I have some connectivity. So it really doesn't matter whether it'll be 6G, 5G or not. I think connectivity and making it available everywhere is essential. COVID has shown us that you can't live your life without connectivity.
Very true.
Business development to explain that, so similarly, possibly for satellite, this whole game will have to be started, that 80% of the vacant place, now you go there.
No, so it has already started. I mean, with the LEOs coming in, there is an initiative called as Community Gateway. I don't know if we have spoken about.
Correct.
So there are community gateway concepts being set up with the help of LEOs, because now LEOs are available everywhere. So basically what they're doing is they are taking an unconnected location and setting up a community gateway which becomes a distribution point like a BTS to distribute connectivity to villages. So that's already initiated and that started. But like Vaibhav already said, yes, we need time to evolve and come to that stage where it will be spread out and connected everywhere.
So we'll take one last question. Yes, sir.
Do you see the HAPS, the high altitude platforms provided by the long endurance drones, augmenting the current scenario?
So there's a very interesting gentleman sitting right next to you from JSAT in Japan. And I'll invite Ken Kunita to answer your question. Ken, why don't you tell them what Japan is doing on HAPS? I mean, talk a little bit about it. Come on. I mean, people out here are interested in HAPS. I mean, I'm hearing India interested. So you're doing so much on it.
Yeah, so in Japan, our company and the biggest telco, NTT, have made a joint venture for the purpose of having a HAPS service in the region, especially in Japan. And we're working with Airbus Alto on this. And what we see in Japan is, of course, disaster relief, and at the same time, the defense. I think there was a session earlier, they were talking about the immediate launch, the immediate demands that can put on HAPS. And what we see is we talk about the direct to device. It's more close to the Earth. HAPS is always closer to the Earth. So basically it's more efficient and more realistic choice for the actual end user demand. However, there's lots of hurdles. Well, the HAPS, there's lots of hurdles to overcome, especially the law, especially the payloads are still heavy. And when we actually tested in, I think it was in Africa or something, but it's about 60 days. We cannot really continue to fly more than 2 months at the moment. So what about the solar energy issues? And there's always this solar energy is, we're talking about the equator. So it's close to the equator, there's a solar energy problem. So if you go to the north side of the world, the flight time will decrease. So there's lots of issues to overcome, but when we talk about the actual user demand point of view, HAPS could be one solution.
Thank you very much. With this, we wind up this session, and now the audience would have understood why the speakers were none from the ground segment. So then only you come out with ideas and opinions, starting from the space to HAPS. Everything could be covered and discussed. Thank you very much, and let's hope to meet next year and dwell more on the same subject. Over to you.
Thank you so much, sir, for such an engaging and thought-provoking session. Well, now at this point, we would like to appreciate the valuable participation and contributions of our esteemed panel members, and to honor their dedication and insights, we'll now proceed with the felicitation ceremony. So I request Dr. Anil Kumar to please come forward and felicitate our panel members. I request our moderator, Mr. Riaz Lamak, President MBC, to please come forward and accept this award. I request Mr. Jayesh Parelkar, Regional Director, Sales and Business Development, Marlink, to please come forward. Now I request Mr. Vaibhav Magow, VP International Business, Hughes, to please come forward and accept our felicitation award. Now we'd like to invite Mr. Pavan Kumar, Board of Director, SIA-INDIA, to please come forward and felicitate our Chair, Dr. A.K. Anil Kumar, Associate Director. I request you all to please come forward to take a group photograph.